Hello friends, how are you doing? And I hope you really all are having a great and fun time and everything is going smooth and awesome, right? We will be discussing the question and answer of the excretory products elimination of the CBSE pattern, right? Let us start with the first question. What is the basic nitrogenous catabolic product of metabolism, right? What is the basic nitrogenous catabolic product of metabolism? The basic nitrogenous catabolic product of metabolism will be always ammonia. The basic nitrogenous catabolic product of metabolism will be always ammonia, right? Now, since ammonia is highly soluble in water, what we will see that ammonia sometimes gets converted into urea, and these will be ureotylic animals. Ammonia sometimes get converted into uric acid, and these will be called as the uricotylic animals. For example, the reptiles, the birds, right, the insects and all that, these are uricotylic. Why? Ammonia is highly soluble in water, so will require a lot of water for its excretion, right? The basic nitrogenous catabolic product of metabolism will be always ammonia, absolutely. We go on to the next question. What are the parts of the renal corpuscle or the Malpighian corpuscle? Absolutely wonderful. The parts of the renal corpuscle will be, first of all, there will be the Bowman's capsule, and the other one will be the glomerulus, and these two together will be forming what? Will be together forming the renal corpuscle, right? These two together will form the renal corpuscle. So, what do we see? Right? There will be the afferent arteriole, and you know what we will see, yes, and this will be the efferent arteriole. Isn't it? The efferent arteriole and the afferent arteriole. So, this is combining of the glomerulus, this is the Bowman's capsule, and the whole thing together will comprise of what we call as the renal corpuscle or the Malpighian corpuscle, right? Then next, in which animal the Malpighian tubules act as the excretory organ? The Malpighian tubules act as excretory organ in cockroach and the grasshopper, right, cockroach and the grasshopper. So, the Malpighian tubules act as excretory organ in the cockroach and the grasshopper, right. We move on to the next question. What is Eureotylism? I have already explained you what is Eureotylism, right. The animals which excrete in the form of urea are the ureotylic animals, and this process is called as Eureotylism. The animals which excrete in the form of urea are ureotylic animals, and the process is called as Eureotylism, okay. The animals which excrete in the form of urea are what? These are the ureotylic animals, and the process is called as Eureotylism, okay. Example are what? The amphibians, the mammals and all. The amphibians, the mammals. So, what is happening basically, ammonia is getting converted to urea, and why ammonia is getting converted to urea? We will see, ammonia is highly soluble in water, and hence, for this removal of ammonia a lot of water will be required. So, highly soluble in water, So, for its removal, will require lot amount of water. However, urea, this is less soluble in water. Right, less toxic, and hence an adaptation for land animals, and that is why the land animals adhered to or changed to the Eureotylism, right. We move on to the next next question. How does the liver serve both as a digestive and even as an excretory organ? Beautiful. The liver is the largest exocrine gland, right? Liver is the largest exocrine gland. Okay. Now, what we said that it serves both as a digestive as well as the excretory organ. So, when we are talking about the digestive function of the liver, and the next one is the excretory function. Right, excretory function. So, when we are talking about the digestive function, we will see that the liver secretes bile. liver secretes bile juice, right. We have seen that the liver consists of hepatocytes, and in the bile canaliculi these hepatocytes will secrete the bile, and from there to the herring duct, the bile duct, and from each of the bile duct what happens, it comes the right hepatic duct, right, the left hepatic duct, and the common hepatic duct, and the bile duct, okay, the common and the hepatopancreatic duct, it reaches the duodenum finally. So, the liver secretes the bile juice, which helps in the emulsification of fat, okay. The bile salts present here helps in the emulsification of fats, And what are the bile salts present? The sodium glucocolate and the sodium taurocolate, right, emulsification of fat. Emulsification is breaking down, okay, emulsification is breaking down of larger fat molecules into smaller fat molecules. So, emulsification is breaking down of the larger fat molecules into the smaller fat molecules. Now, when we talk about the excretory function, see, liver is the principal organ of excretion after kidney, we can say. So, what is liver doing? Liver is basically converting, okay, is forming urea by ornithine okay, ornithine cycle, or the Krebs-Hanslet cycle, or the urea cycle, okay. So, the urea is formed here. What happens over here? There is deamination, okay, of amino group in the liver, and urea gets formed. Also, what happens, in the, see what is happening, the bile juice is also containing some of the pigments like the bilirubin, biliverdin, which is removed in the urine, and also here we have some amount of cholesterol, which will ultimately, from the bile juice, the cholesterol and certain drugs, okay, cholesterol and certain drugs are also removed by the liver, So, hence it also plays a very important role in the excretory function. Okay. Now, we move on to the next question. Is the ultrafiltration process in the glomerulus a passive or an active process? Ultrafiltration, okay, ultrafiltration in glomerulus, right, is a passive process, okay, is a passive process. It does not require energy, is a passive process, not requiring energy, This is due to the difference in pressure, okay, and the ultrafiltration is also mainly contributed by the difference in the lumen of the afferent and the efferent arteriole, right. So, this is also contributed. This is also contributed by the difference in lumen of the afferent and efferent arteriole, right. This is also contributed by the difference in the lumen of the afferent and the efferent arteriole. So, hence ultrafiltration in the glomerulus is a passive process. We move on to the next question, right. The chances of kidney failure are more in those who have the high pressure, right. Why? Now, as I told you, right, these are the glomerular capillaries, this is the afferent arteriole and this is the efferent arteriole, right. The blood is flowing from here and then it goes all the way through and it comes out through the efferent arteriole, that is the exit arteriole, this is the Bowman's capsule, and the glomerular capillaries together called as the Malpighian capsule or the Malpighian corpuscle. Now, if there is high pressure, high pressure means high pressure of blood. So, what is happening, the blood will come at a very high pressure and enter this arteriole, enter at a very high pressure. Now, when it is passing through these glomerular capillaries, what happens, what happens because of this high pressure, these capillaries tend to, disrupt, and hence there will be a kidney failure. Thus, because of high pressure, the pressure of the blood entering the pressure of blood entering the afferent arteriole would be high. The afferent arteriole would be high, right. This is because of high pressure, the pressure of blood entering the afferent arteriole would be high, and hence the chances of disruption of the capillaries would be high. Okay. We move on to the next question. Why is reabsorption described as a selective process? Now, reabsorption is the absorption of certain products or certain substances rather of certain substances. Okay. like glucose and all, like glucose and all in the distal convoluted tubule and the collecting duct, in the distal convoluted tubule and the collecting duct, and the collecting duct. Okay. Reabsorption is the absorption of certain substances like glucose and all in the distal convoluted tubule and the collecting duct. So, what is happening, this, what do you mean by selective? It is selecting substances, not all substances going through the filtrate is reabsorbed. If urea is passing, it will allow urea to pass. If creatinine is passing, it will allow creatinine to pass. But when sodium, when glucose, when other important substances are passing, and that is why it reabsorbs them back into the what? Into the medullary region or the medullary interstitium, whatever, from the filtrate, and that is why we say that it is a selective process. Hence, as only selective, okay, hence as only selective substances are reabsorbed, thus called as a selective process, called as selective process. Okay. We move on to the next question. Describe the role of ADH and countercurrent system in the formation of the hypertonic urine. Now, what is ADH? Quickly, we will see ADH is nothing but the anti-diuretic hormone, which is also called as the vasopressin, which is released from the posterior lobe of pituitary. Okay, released from the posterior lobe of pituitary. Posterior lobe of pituitary, right. The ADH is the antidiuretic hormone or the vasopressin released from the posterior lobe of the pituitary, and what does it do? It reabsorbs water from the distal convoluted tubule and the collecting duct. This reabsorbs water, right, from the distal convoluted tubule DCT, that is, and the collecting duct right. This reabsorbs water from the DCT and the collecting duct. So, this is the role of ADH and countercurrent system. And then we will be talking about the countercurrent system. Now, countercurrent system is formed by the loop of Henle and the peritubular capillaries and the vasa recta, formed by the loop of Henle and peritubular capillaries and vasa recta, right. The countercurrent mechanism helps in the absorption of sodium and other electrolytes, right. This helps in fact absorption of actually water. This helps in the absorption of water from the filtrate. So, when it is actually absorbing sodium and the electrolytes, even the water is getting, is coming out of it. So, this helps in the absorption of water from the filtrate, thus concentrating the urine, thus concentrating the urine. So both is concentrating the urine and hence producing a hypertonic urine. ADH is also absorbing, reabsorbing water, and even the counter current mechanism is reabsorbing water from the urine, right. So now we will move on to the next question. Now we will move on to the next question, and so what is the next question? We will see what are the normal and abnormal constituents of urine. When we talk of the normal constituents of urine, what we will see that it has both the organic and the inorganic part, and in inorganic there will be the sodium, the chlorine to very minor extent and all that. Okay, this basically has urea, okay, creatinine, hippuric acid and all that, hippuric acid. Okay, when we talk of the abnormal constituents, then if you see the glucose, right, glucose and other constituents okay, and anything above the normal constituent would be abnormal in the urine. So friends, finally we have come to the end of this discussion. I hope you have followed this. Any doubts, you can always come back to me the time we meet again. A very goodbye from this side. Thank you.